So if somebody's just joining, we're about halfway through the seminar. The first talk that I just gave was about the mission idea contests as a whole. MIC1, MIC2, pre-MIC3, and then MIC3. This presentation is going to be specifically about MIC3, and it's kind of a design and application guide. So how to approach the idea generation process and how to initiate the design process and start filling out the application. And again, like last time, if you have questions at any time, just jump in, or at the end we can address them all. So this is what I want to talk about. To start with, really what is this mission idea contest? Well, it's a form of project-based learning. It's not just some strange thing that came out of nowhere. So I'll talk about the background of these types of projects, and then again I'll talk more about our motivation. I mentioned it before. We want to do this innovative exploitation, but I want to focus here more on problem solving, and I'll tell you what I mean by that. Then we'll talk about the process itself, generating ideas, checking for novelty, design strategy. I'll give a guide to the report template, and then I'll talk about some common pitfalls that we've noticed teams making over the last few years. I'll reiterate the schedule and then put up my contact information again for anyone who needs additional guidance. So, to start with, MIC3 is a form of PBL. What is PBL? It's project-based learning. It's learning by doing. It's a form of education that's gaining popularity. And we want to solve real-world problems or open-ended questions or challenges. And it requires creative thinking. It requires some essential content and skills. And we need team members to think critically together, collaborate, and communicate. These are sometimes referred to as 21st century skills. And it's for MIC3 it's not required, but generally in this process, student voice is welcomed and encouraged. And feedback and revision is a mandatory part of the process. And we want the results to be publicly presented in the form of a performance or a product. So this is just a summary of what I said. PBL, solve a real world problem or some open-ended question or challenge. And this is what it takes. Create something new, use 21st century skills, provide feedback and include group member voice, and publicly present the results. So, what is our motivation? Well, MIC3 and PBL in general share the following. This is with respect to satellite design. Technical prowess. We want our members to, if they're students especially, to be doing something on the order of, you don't have to be a bachelor's, master's, or doctorate student, but we want you to be thinking at least on that level, on the level of research at the undergraduate or graduate level. In addition to that technical prowess, we want teams to employ systems engineering. And these are some examples of small satellite projects in Japan, at least through QTech, 4U4, 4U3, and of course there are many programs that have been part of CONSOC and ARLIS. Additionally, we want team members to think as global engineers with a broad scale, scope, very, very broad thinking. We want them to also have or develop intercultural communication skills. We don't want ideas limited to just one city or just one country. We want to think more globally and interculturally. So, that being said, those all sound very good. Those are things that this idea contest promote. What are some drawbacks? Because we may have many large teams, sometimes social loafing occurs, and that's where one or two people in the team drive the project and the others don't really learn or gain as much from the experience. So that's something that each team needs to work on overcoming. Also, depending on the project, there may be a lack of technological depth. But what we want for this contest is an idea, an outline, and an approach that says, is this idea feasible or not? If there's not significant technological depth, if the idea doesn't lead to a doctorate thesis, that's okay. But later, as the project develops, it likely will get there. And this is just a note, and that's that the majority of successful innovators really make incremental changes with respect to their own work. Somebody who sees that project from the outside sees an enormous leap forward. Something springs into existence that they never could have imagined. But for those people who are working on that project, it's really a progression that happens over time in most cases. So don't worry if you don't have a magical idea that solves the world's problems. It's okay to move your own field forward incrementally, or your own idea forward incrementally. It could lead to very, very drastic results. So, all of that being said, my suggestion for this contest is to think big picture. Try to make an extensive impact, have a broad vision. And those sound like contrasting ideas. I'm saying it's okay to think incrementally, but I'm saying, go big picture, have this extensive impact. Well, first, have the idea, and then find a way to leap forward. And you may need to leap forward incrementally, but think about something that has a large-scale impact, or can be scaled very, very, very quickly. Okay. Next, how to do this, or what should we be thinking about? So, from a user standpoint, this is what most people associate with. They think, how can this help me? It's okay to personalize this process. Of course it works to think about problems in the world and try to solve them, but often it helps to personalize. So, what individual, regional, social, national, or global application exists, or doesn't exist, that could be useful to society? What problems are faced? For example, there could be drought in part of the world that needs to be monitored or predicted. There might be forest fires that cause millions of dollars of damage or take many, many lives that could be mitigated with satellite technology. It could be something like solving traffic problems. It could be something like communicating in remote areas of the world where cell phone service or internet isn't available. So there are many problems that satellites can help with. And more importantly, what are the obstacles to solving these problems? And that's where you can be very creative. How to overcome these obstacles? Well, first you need to identify why hasn't it happened already? And then finally, once these questions are answered, or somewhat answered, what are the mission objectives and priorities of your actual idea? Then, from a developer standpoint, from a technical standpoint, we need to bring the idea to life. And this is where hardcore engineers and scientists can really have fun taking the idea and making it happen. So, in the pre-MIC3 workshop, some people watching this maybe participated. We tried to match users and developers, user teams and developer teams. It was difficult. There were some problems with people working together on very short notice because we put them together at the conference. So we want teams to think as both users and developers and submit one unified idea, mission idea and satellite design, that incorporates both of these aspects. And this is just a quick discussion of different space activities. It's very general. This is not specific. You will have a chance to think of specific ideas. But in a general sense, there are 5 types of high-level space activity that benefit developing countries. Of course, the ideas are not restricted to developing countries, but it's one area where a large impact in society could be made. So applying satellite services, like an example of a satellite service is satellite TV. Building technological capability. This could be something like high-speed communication. It could be something like GPS. Enabling economic activity. This could be based on satellite imaging, satellite images, and more importantly, the information extracted from those images can be very powerful to different economies. Inspiring technology applications, so inspiring a new era of technology based on space applications. And finally, building scientific knowledge. So we don't have to come up with a mission that has an impact on society by solving an immediate problem. We could have a much larger scale impact by making a scientific discovery or making a contribution to science that leads to some much larger impact on society in general. So this is another key factor that benefits the whole world, not just developing countries. And 3 primary areas of need that these categories fit into: remote sensing, navigation, and communication. These are 3 big areas, especially for developing countries. In this seminar, we won't really talk about specific ideas. If you have some questions, we can briefly address them, but one-on-one or with individual teams, I'll talk about your specific ideas, but at this point, I don't really want to talk about other people's ideas. I just want everyone to think about how to make an impact, how to generate your own idea. And it doesn't matter at the beginning if other people have already thought of your idea. The important point is that you be creative. You don't confine yourself to rules. You don't confine yourself to some restrictions. Just imagine a problem or a situation that could be improved or solved, and think about how it should be done before you think about how it could be done. Think about the best way to do it, and then you can find out how. Of course it's necessary, but I want you to be creative from inception. And this is something to remember. It's very important for this contest and for the small satellite community in general. Small satellites individually offer some but few advantages with respect to their traditional satellite counterparts. For example, if you have the option of a 50 kilogram satellite or a 500 kilogram satellite, the 500 kilogram satellite, independent of cost, is going to, even if you include cost, is going to provide vastly more service, vastly more knowledge and utility. Even though it costs more than a 50 kilogram satellite, it only costs a little bit. But if you have a constellation or network of small satellites, then we start to realize major advantages over traditional satellites. So it's not necessary for a single mission, but it's one area in which small satellites can gain a huge advantage over traditional satellites, and that's when you make a constellation or a network. Okay, now we'll get into the core part of this presentation, and that's the novelty check. So, after you think of an idea, and you think it's a good one, you come up with something that will make you rich and famous, you have to ask yourself, have you seen or heard about a similar idea before? And if you haven't, that doesn't mean that the idea hasn't already been realized or hasn't already been thought of. So you must, at that point, start searching for similar ideas or similar ways in which this was done. Two, are there, and even if that's true, probably you'll find a similar idea, are there new and original parts to this particular idea that you had? So it's okay if you thought of doing something that somebody else has also thought of, if you thought of doing it in a new way, a creative way, or an innovative way. That's okay. To check this, the answers to these questions must be validated with literature review as part of the application. If you don't do that, if your team doesn't do that, it stands a very low chance of being selected, and your idea may struggle to gain steam in the community. So find out what attempts have been made to solve the problem. You can start with an internet search. You can look in journals. You can look in libraries and books. You can talk to me or other professionals in the field, and reference previous attempts. It's not good or bad if there's a lot or a little literature about your idea. It could mean that it's a really difficult problem and you're finding a new way to do it, or it could be that just nobody's really thought of it very much before. So reference previous attempts or reference the technological hurdles. If you have a totally new idea or technology, and literally you can't find any mention of it, it's truly new, that would be wonderful. In that case, you must justify the feasibility and basic principles to show that not only is it new, but it's new and there's no mention of it, not because it can't be done, but because you're just very brilliant, and then justify the feasibility. So this is a comment from a reviewer that I included here, and I highlighted the red parts that are important. So very many of the first round proposals, that's the abstract style proposals, suffered from fundamental misconceptions that had been described in open literature. So this is saying there were just problems or ideas that were openly available to the general public. So make sure that it has not already been done, and confirm the basic feasibility before you submit your abstract. And this reviewer suggested that in addition to the literature check, each team should consult an experienced advisor or mentor who could review their idea and provide guidance. And I strongly recommend that as well. So design strategy and documentation. My suggestion, and you don't have to follow this is just a suggestion if you're not really sure how to start, is to do this. This is the first step for design strategy. So, number one, originality. That's what we've been talking about. You have this idea and you check it. Is there a similar idea that you've heard of before? What are the new and original parts? Number two, rationale. You have this idea, that's great, but is the motivation behind your idea sufficient and logical? So sufficient means, is there truly a need? What problem are you solving that impacts society or science or some other community in a significant way? And is it logical? It should appeal to some subset of the community or of the region or world in a logical sense. Number three, technical feasibility. I think most people here in this community are engineers. They're good at this part, the technical feasibility. So apply basic engineering and physics concepts to the critical aspects of the design, and then ask yourself, does the proposed mission pass the test? For example, what camera resolution is required to detect pirate ships? If your ship is this big and your resolution is this big, you won't satisfy the mission. The ship could go anywhere and you won't be able to find it. So if you need a certain resolution, then you need to ask yourself, is that camera design feasible for a less than 50 kilogram satellite, since we're constrained to that mass by the MIC3 rules. Why or why not? So we can do this for all aspects of your design. Complexity, here we outline the necessary satellite components, so the payload, and then all of the subsystems that are required to operate this payload successfully in space. So this is really from a satellite standpoint. Number two, we need to think about the bigger picture. So not just the satellite, but the entire mission. So first, select the satellite systems, the payload systems, for example, a camera, a laser, some biological experiment, etc. And then the bus systems, like power, communication, the onboard computer, etc. Number two, define the mission requirements. By mission requirements, I mean, what must each subsystem accomplish? What is the minimum level of success for, what is the minimum level to succeed for each subsystem? That likely comprises technical specifications, components, and simply what it needs to do. And there will be a corresponding size and mass, power, voltage, etc. Number three, once the mission requirements are defined, select an orbit. These two are really together. But number three, select an orbit. So if you know what your payload must do, you should know where it must go in order to satisfy the goal. So we might use STK, we might just do analytical calculations, but there needs to be verification. Number four, define mission modes. So you know what your satellite wants to do, you know where it's going to go, but now what are the operations and activities that your satellite must carry out and in what order? So here, we don't just think about the mission modes from the satellite standpoint, but how do we carry out the entire mission from design and operation to launch into orbit, to initiation and then communication with the ground station, and finally termination at the end of life. So this would be the entire life cycle, including the ground station, I should say including design, testing, launch, operation, and end of life. And included in the design would be detailed satellite design that shows interfacing between subsystems and modeling of the satellite itself, and figures that show the satellite operational diagram. So these are figures that show what I was describing in as each segment: ground segment, launch segment, space segment, etc. So again, this is just an overview that I think is useful. But anything can be, this can be tailored or not used. It's your choice as you see fit. What documents might assist you? Some of these are asked for in the application, so they're somewhat mandatory. But of course, tweaks can be made. But this is just a non-comprehensive, non-mandatory list of documents that might be useful during the satellite design. So mission requirements, orbital selection, table showing mission modes, subsystem block and functional diagrams, an interface control document, mating subsystems, CAD, computer-aided drafting models, system level operational diagrams. This is actually one that I strongly recommend. The system level operational diagrams show, first from a satellite standpoint, what the design is doing, and also from an operational standpoint, where does the satellite fit into the entire process? That's ground, launch, satellite, maybe a ground station network, etc. Some risk analysis. The last two are commonly used documents, verification matrix, and breakdown structure. Maybe not really necessary until the later stages in the project, but it's something that you can consider. You can just Google these terms and you'll get an example of what they are. So, we're getting close to the end. The next thing I'd like to do is just briefly talk about the report and what to do from in a very pragmatic sense. So, there are 100 points. This is the evaluation criteria that each team will be scored on. And this chart is online. It's on the poster that I handed out. The right side is the originality category, novelty and impact on society. The left side is the feasibility category, operational, programmatic, and technical. So, how do we make sure that our idea addresses each of these 5 points? It shouldn't be so difficult because the abstract and the report are very well outlined. The templates are very well outlined. So, what I put here, I put the 8 different chapters that are in the template. For the abstract and the final report, the chapters are the same. There are 8. Maybe I shouldn't say chapters, but 8 different headings. So, the introduction and need, mission objectives, concept of operations, key performance parameters, space segment description, orbit constellation description, implementation plan, and references. What I've done here is I've put each of these 5 categories under one or more of the different headings. This is just my suggestion. Of course, you can choose to address these 5 points in some other way, but this is a fairly logical approach to making sure that all of your points are allocated appropriately, or all of your attempts to gain points are allocated appropriately throughout the document. So basically, the right side of this pie chart, the originality, is mostly addressed in sections 1 and 2 and in the references. So references meaning list your references here and talk about them in detail in 1 and 2. And the left side of this chart, the other half of the points, are mostly talked about in sections 3 through 7. This is something I mentioned earlier. Number 7, the programmatic component, is almost entirely discussed in section 7. And it's worth, I guess it's worth 15. I mistakenly said 20 earlier. It's worth 15 points, 15%. So maybe it's not quite as drastic as I thought. 15% maybe in just one section. But again, you can't change the sections, but you can try to describe different components of your project in a different way. This is simply my suggestion. So finally, some common pitfalls, some common problems that we've noticed teams encountering. Number 1, this is also non-comprehensive, so just because a problem's not here doesn't mean that people aren't making it. But these are 4 common ones. Number 1, an unrealistic cost analysis. One thing you could do is use a model by Professor Nakasuka from Tokyo University. And if you don't know where to find that, you can ask me, or you should be able to find it on the website or online. Number 2, the required satellite testing is undefined. It's great if you can design a satellite, and probably it's a reasonable design, but if there's not some way to verify that the satellite will actually operate in space, that it can survive the launch environment and the space environment, that could hurt your application. And if you'd like to get an idea about what testing can be performed for nanosatellites, look at this website. This is the Center for Nanosatellite Testing here at QTech. Number 3, some method of contacting users or some way of implementing the business model. So we get lots of proposals that have very articulate and well thought out and well considered engineering designs, practical designs, but they don't consider how to implement the plan from a technical standpoint, that is all segments of the operation, from ground to orbit to end of life, but also, more importantly, from a user standpoint. How do we actually take the satellite, take the technology and make an impact on society? It's great to say that it will make an impact, but how do we, in a quantitative sense, ensure or define what our goals are to have this impact on users? And number 4, I've mentioned this numerous times, an inadequate novelty check, so just not enough literature review of what's been done before. If you would like details about any of these or any other points, just ask me. Also, I have a PDF copy of general reviewer feedback from a previous mission idea contest that has more details about some of the problems that have been seen. Oh, okay, we're nearly done. So this is my suggested project mode or project modes to avoid some of these common pitfalls and to approach the problem in multiple with multiple facets instead of just focusing on the satellite design. So what you could do is split your project team into the following 3 categories. One team could act like a user and work on the business model, or in other words, find a way in which the satellite idea, the mission idea, impacts people on the ground or the scientific community, etc. And then, of course, there will be a developer team that handles the technical design from a bus system and payload system standpoint. And third, a team that works with management, integration, launch, schedule, cost, the ground station, and data sharing network, etc., etc. So this is just my suggestion. There are many ways to do this and be successful. Finally, just a reminder, again, you missed it before. Today is April 4th, 2014, and the deadline for the abstract submission, 5 pages maximum, is June 27th, 2014. And finalists will be notified September 1st. The final paper will be due October 15th for the finalists, and the presentation will be November 19th, 2014, here in Kitakyushu at the 2nd UNICEF Global Meeting. Again, in case you missed it, my name is John Polanski, and this is my contact info. The other coordinator in Japan, Professor Shisaka, his contact info is here. All regional coordinators can be contacted through their profiles at this website, and the MIC office can be contacted via email, phone, or on the website. Thank you.